In this lab, we're going to take two chemicals, sodium bicarbonate and sodium carbonate, mix them with an acid, and make table salt. Now, the point of this lab is not just to make salt, it's to predict how much salt we will make using stoichiometry. We're going to take the skill we practiced in class and apply it to predict how much salt we will make from sodium bicarbonate and from sodium carbonate. Before we get into the lab itself, let's talk a little bit about the chemicals we'll be using and the safety around them. Our first chemical is sodium carbonate. This chemical is relatively benign. You can actually find it in a lot of grocery stores as washing soda. It's not that dangerous, but it is a powder, so we want to keep it obviously out of our eyes. And if it does get on your skin, just rinse it off or brush it off. Sodium bicarbonate is actually just baking soda. So this also very benign, just a powder. Again, wash it off, wipe it off if it gets on your skin or clothing. Our last chemical is going to be hydrochloric acid. This is what we're going to use to actually create the salt with our two carbonates. Now this is 3 molar. It's rather concentrated. You don't want to get this on your skin. If it gets on your skin, just wash it off. But if it does get, you don't want it to get in your eyes most of all. That's why we're going to wear lab goggles for this whole class. If you want to wear gloves, you can, but honestly, if you get it on your skin, you can wash it off pretty quickly and you'll be okay. Now, the first step in this lab is we're going to weigh our dishes. There's really two parts here. One is our watch glass, and two is our evaporating dish. This is what we're actually going to perform our reaction in. The first thing we need to do is get the weight of just the evaporating dish and the watch glass, because eventually our product's going to be stuck in here. So we need to get the weight of both of these together so that at the very end, we can subtract that weight away. I'll put these both on the scale. I see that the mass here is 75.66. So this is the first weight I will record. We just hold on to that for later. Now I need to weigh my chemical into the dish. I'm going to take off the watch glass, and with the evaporating dish still on the scale, I'm going to zero the scale. Now, I need to weigh into my evaporating dish between 0.3 and 0.4 grams of sample. And the less you use, the better. So I will get my sample. For this, I'm using sodium bicarbonate, but eventually you'll use both. And I will slowly tap in my sample into my evaporating dish until I hit 0.3 grams. Now, this is not a lot of sample. Really, I'm going to use a tiny bit of sample. Need just a little bit more to get 0.3 grams. And right here, I have 0.3 right on the dot. And I'll show you what that actually looks like. It is a very, very small amount of sample. You can barely see it there in the bottom of the watch glass, or the bottom of the evaporating dish. You also want to record that weight of sodium bicarbonate. My scale fluctuated here a little bit. Now it's saying 0.29. So whatever the weight of your sample is, you're going to want to record that as well. In the next part of the lab, you're actually going to perform the reaction. Now for this reaction, I'm going to take my hydrochloric acid and mix it with my sample. I don't actually have to record how much hydrochloric acid I'm using. We're going to see that we're going to run out the reaction by kind of overloading it with hydrochloric acid. Now, when I slowly drip this hydrochloric acid in, I will see this fizzes. You can hear it a little bit there. And I'm going to put just a little bit of hydrochloric acid in to start, a few small squirts. Because this is fizzing, this is putting off carbon dioxide, and it's showing us the reaction is still proceeding. I'm going to swirl this gently to make the reaction go. Once the swirling subsides, I'm going to drip in around like 10 or so more drops of hydrochloric acid. I hear it still sizzling. I'll swirl it to mix the components. And I'm going to repeat, putting a few drops in and swirling until no more drops form. Now, I actually put in enough hydrochloric acid, it seems like, in that first kind of burst to fully react this. I don't hear any more sizzling. Now that I've fully reacted my sample, I have salt in this evaporating dish, but it's dissolved in kind of the water that was in that hydrochloric acid. So there is salt in here, but it's dissolved. So in our next step, we're going to get rid of all of that water. In the next step, we have to boil off that water. So we have our sample, that's our salt dissolved in water. We have to boil off that water to just leave us with salt. What I'm going to do is I'm going to take this and set it to the side for the moment. I'm going to put a watch glass so that it's inside of the evaporating dish. The curve should be going into the dish. And I'll set that to the side. I now have to assemble my ring stand. Now what I'm going to do is take my ring stand and I will take this iron ring. I'm going to fix it around halfway down or so, the ring stand. Now we want to boil off the water. We want to make sure it's in a hot part of our Bunsen burner flame when we start this up. So what I'll do is I will start the Bunsen burner flame. I can get a good spark with my striker, turn on the gas, turn on the Bunsen burner flame. Now I can see my flame, the tip of that inner blue cone is down around this level. I'm going to adjust my iron ring away from the Bunsen burner so that the bottom of the iron ring is a little bit above the top of that inner blue flame, that light blue flame. The reason is we want our evaporating dish to sit in here and have the bottom right around the tip of that inner blue flame. As I'm assembling this further, I'm going to shut off the gas because I've got this level the right spot. Now that my Bunsen burner is off, we need to put one thing on this iron ring to start. We have to put this wire mesh on the iron ring. Now, I kept this all away from the Bunsen burner, so it's cool. If you had kept this near the Bunsen burner, this metal might be very hot. So keep this away from the Bunsen burner when you're getting things set up. This mesh here, it has a tendency to kind of wobble if you aren't careful. What I'm going to do is I'm going to push the mesh into that ring a little bit, just to give it a little bit of stability. And then I'll then take my sample and place it right in the middle of that iron ring. And I notice that it's pretty stable. I'm not seeing it wiggle around a little bit because I pushed that mesh in. Now we can boil off the water. Let's turn on the gas, turn on our Bunsen burner, and I'll put my sample over the Bunsen burner. I could honestly go a little bit lower over the Bunsen burner. While this is still cool, even though it's over the Bunsen burner, if you feel comfortable doing so, you can lower this a little bit, but you have to be very careful and very slow so your evaporating dish doesn't dance off. If you're like too fast with this or not careful, your glassware can fall off of this. Call me over if you want to move it down, but you're not comfortable doing that. Now this is going to take a good 5-6 minutes or so to fully boil off. I'm going to have to adjust the height a little bit. As this is boiling, you should use stoichiometry to predict how much salt you expect to be left. We know our mass of sample to start, and we know our reaction, so we should be able to predict a mass of salt at the very end. Now this is boiling, I'm going to let it go until it's fully dry. Now that my sample is dry and it's cooled off a little bit, still a little bit hot though, so I'm going to use these heat resistant gloves. I want to show you that there's actually a little bit of salt all over the container. You can see on the watch glass we have some of the dried salt, and in the container itself we also have a bunch of dried salt all around the bottom. Now it's stuck in our container, so to get weight, we're going to have to put this entire assembly, watch glass and evaporating dish, on the scale, and then subtract out the weight that we originally took. Now, in pretty much our last step, we just have to take the weight of our watch glass, evaporating dish, and the salt that's left behind. I'm going to zero my scale with nothing on it, and I'm going to place my watch glass and evaporating dish on the scale. And we can see that the weight is 75.87. Now, if I subtract out that original weight of evaporating dish and watch glass, I'll get the weight of just the salt. And we can compare that weight to our predicted weight that we predicted using stoichiometry. Now, you'll do this lab twice, once for the reaction using sodium bicarbonate and once for the reaction using sodium carbonate, and you'll see what the difference is. And you want to compare those differences to your original equations. You should see some conclusions about stoichiometry kind of pop up there. And that is it for the stoichiometry lab for section or unit 4, section 3.